Dear technicians, welcome to my video today. Today we will be talking about the sections of a power bank. By understanding the sections of power bank, you will be able to diagnose and then get a meaningful result and provide useful solution. The same way mobile PCB has a section, that is also the same way power bank has a section. Now, if you look at it from a mobile phone perspective, we have charging section, we have power section, we have network section, there is display section, on the CPU of it. Those sections have their own function separately. The phone problem will determine which section are you going to work on. The same way PCB of power bank were built in order for them to be able to work efficiently, they were sectioned. Now, because PCB of power bank are so small in nature, so they have smaller section. The two most important section in power bank is charging in section and then power section. Charging section and power section are the two most important functions. And if you look at the functions of power bank itself, is to receive charges and then to give out charges. Now, where is the trick lies? The trick lies in voltage. What do I mean by that? Now, reason with me. You inject 5 volts. Remember, the battery capacity is 3.8. No matter how big the battery can go, it cannot go beyond more than 4.2. And the lowest, I think, it can even go up to like 1 volt if the OVD is bad. It can go down to 1 volt. Now, the real trick there now is that if you remove a charger, because if you are charging your power bank, it cannot provide charges for you at the same time. So if you remove your charger, we are having 3.8 on the battery itself. Now, the 3.8 we have on the battery, how does it give us 5 voltage? There is a section responsible for that. I hope you understand like that. Now, this PCB I'm holding, I will use it to give you a critical example. There is a MOSFET IC there. That MOSFET IC, it can come in different shapes and patterns. This one has 8 pin. There are some with 6 pin. There are some with 12 pin. That is the U1. It was used as U1 IC here. Now, there is another component IC there. That one is U2, as you can see. Now, these two important components, they work hand in hand. If one is missing, the PCB will not function. Now, why do they have to work hand in hand? Both of them combined is what we call power bank. One cannot function without another. But in order to understand this very well, we need to return to the early era of power bank, whereby we are having only MOSFET, diode, inductor, and coil. Their functions for the two. We don't usually have a couple of IC back then. But now we're having 2 ICs. That's why we have U1 and the U2 at this moment. There are some that can even have up to like 3-4 IC. And the output is usually type C. Some are uni, while some are bi. Those uni can only receive charges, while the bi can give out take at a time. So now, let's proceed further. MOSFET function in a PCB of power bank. From one model to another, their functions are different. That's why you cannot bring anyhow MOSFET for replacement. It is not going to work, and that MOSFET is not bad. it has been encrypted. It has a configuration. It's a mini chip that was coded. So depending on the configuration, if the configuration doesn't match the PCB that it was taken to, is not going to work. So there is more to this video. You can like, comment, and share.